Let us move on to the next topic. Sometimes you must have heard that this is half of something, give me half of the pizza or give me half of the chocolates, right? So, of is also an operator. Remember when you have done BODMAS rule, BODMAS, which stands for brackets, then of, right? Then divide, multiply, addition and subtraction. So, what is that of in that? It is nothing but only multiplication, but we give it a priority over multiplication. Let us see some examples of it. Like if I give you here 2 squares and out of these 2 squares I found, if I shade the part, I say one part out of 2 are shaded in the first square. Similarly, I can say one part out of 2 are shaded in the second square also. So, how many parts are totally shaded? So, there are 2 parts which are shaded. So, how can I write it? These 2 are exactly similar, and here the each shaded portion is half of one whole, right? It represents half of one. Half of one means here it is the first square and you are shading the half part of it. So, both the shaded parts together will represent what? Half of 2, right? Together if I say, that means half of 2 will give me what? I can simply write half of 2. Combine the 2 shaded half parts, it will represent, see, you can see here one complete shaded part. But how we can get that also? This is half of 2, right? Because you are getting one complete square. And half of 2 means of, just it is replaced by the sign of multiplication here. So, half of 2 means half multiplied by 2. And again we have done in the previous segment only, whenever we have to multiply a fraction by a whole number, we simply multiply the whole number by the numerator. That is, we multiply 1 by 2. Or in other words, you can also say that here we are actually cancelling 2 times 1, 2 times 1. So, 2 ones are 2 and 2 ones are 2. So, what is the result here? 1 times 1. The final result is 1. And any fraction with the denominator 1 will be equal to the numerator. Like if I am writing 1 over 1, the result itself will be 1. It is applicable to any of the fraction. Like if I am writing any number 2, I can also represent it as 2 over 1. If I am writing minus 5, I can also write as minus 5 over 1. Because if you are dividing any fraction then by 1, then you are getting the same number here again. The same integer again you will receive. Like if you are having 5 chocolates and you want to give it to one of your friend, you will give whole 5 chocolates, right? All the 5 chocolates will be given. So, 5 divided by 1, the number you will get is 5 only in this case. Now, let us proceed with one more example. Let's suppose 3 squares are given and half part is shaded. So, in this case, how many parts are total shaded? There are 3 parts totally which are shaded. But out of what? So, here you can see half of 1 is shaded, right? And so, we can say half of 1 out of total. How many times it is being repeated? So, it is repeated 3 times. That means we can say it is half of 3 because half is repeated 3 times. So, first square, second square and third square. So, combine the 3 shaded parts, what you will receive? It is half of 3, that is half multiplied by 3, which is nothing but equal to 3 over 2. And 3 over 2 is nothing but a combination, it is an improper fraction. And an improper can be written as a mixed fraction. So, if you divide 3 by 2, you will get the quotient as 1, again the remainder as 1 and the divisor is 2. So, we can write 3 over 2 as one whole number 1 over 2. Now, proceeding further, we have some questions for you here, like find what is half of 10 what is 1 over 5 of 16 and 2 over 5 of 25. So, in this case, you may find the result may be a fraction, it may be a proper and improper fraction, or you may get the result as a whole number also. Just try these questions and conclude it. Now, let us move on for the next segment, that is multiplication of a fraction by a fraction. See, now you got to know if we multiply a fraction by a whole number, simply we have to just multiply the numerator by the whole number, keeping the denominator as same. But what if two fractions are getting multiplied? So, in this case, it's a very simple again. Multiply the numerators, that is the top numbers which are written on the top, and multiply the denominators. Very simple. And if needed, you can simplify it further also. That is, you can reduce the fraction to the lowest form. Remember what you have done in your previous grades again here? So, we have a formula over here, that is the product of fractions is equal to the product of numerators divided by the product of denominators. You need to just remember this. It's a very simple and a very interesting one, just simply multiplication is there. Here, let's see an example. Like if you have to multiply 3 over 4 by 7 over 6. What you have to simply do? Just multiply the numerators, that is 3 times 7, and multiply the denominators. So, 4 times 6. And what is 3 times 7? That is 21. And what is 4 times 6? That is 24. Now, 21 over 24. Can we reduce it further? Yes, we have a common factor 3 between the number 21 and 24. 21 and 24, they both come in the table of 3. That means we have 3 is the common factor here. So, if I divide or if I cross, cancel, whatever you say, if we cancel it by 3 or if we divide it by 3, what we get here? See, in the table of 3, I get 21 7 times, and in the table of 3, I get 24 8 times. So, my result will be 7 over 8. So, isn't it very simple how to multiply the fractions by the fractions, right? Let us see one more example with the value of the products. How to get the value of various products, that is product of two whole numbers, is it smaller or is it greater? Let us see with an example. Here the product of two whole numbers is bigger than each of the two whole numbers, that you easily know. Like if I multiply 3 by 4, the result I will get is 12. And here the final product 12 will be greater than 4 as well as by 3. That means 12 final product will be greater than the individual numbers. And remember the properties of factors that we have discussed in grade 6 already. What does it mean? It shows that here the final product should be always greater than the factors. 3 and 4 are the factors of 12, and yes, 12 will be greater than 3 as well as by 4. But is the same thing true for fractions also? Let us see. Now, let us see what happens to the value of the product when we multiply two proper fractions. For example, if we take 2 by 3 and 5 by 7 as two proper fractions and we multiply them, then see what we get. We simply multiply the numerators to get 10 and multiply the denominators to get 21. Now here the two proper fractions are multiplied to give one more proper fraction, right? You see 10 is smaller than 21, so 10 over 21 is also a proper fraction. And now here we conclude one thing here, that whenever we multiply any two proper fractions, then the product is less than each of the fraction. Just see the final product 10 over 21, it will also be smaller than the individual proper fractions. That means 2 over 3 will be greater than 10 over 21 and 5 over 7 will also be greater than 10 over 21. You can relate it with one very simple example also. For remembering, you can just take an example of 1 over 2 and 1 over 3. So, these two are also again the proper fractions, and if you multiply them, the result will be 1 over 6. So just relate now. 1 over 2 is when one whole is divided into two equal parts. Each is called as 1 over 2. Similarly, 1 over 3, the same part, if I divide into 3 parts and I get 1 part out of 3, right? So I get 1 over 3. And 1 over 6, if I say, the same 1 part, if I divide it into 6 equal parts, 1, 2, 3, 4, 5 and 6 equal parts, then 1 part here will be representing 1 over 6. So now it will be very easy to learn this particular statement and to understand this as well. Whenever two proper fractions are getting multiplied, see the final result, it is smaller than 1 by 2 also, and it is smaller than 1 by 3 also. So you can apply the same rule to all the proper fractions product also. That means whenever we are multiplying or whenever we are finding, the product is always less. The final answer will be less than the individual fractions always, right? But what if we multiply to improper fractions? So, will the equality or inequality remain same? For example, let's take, if I multiply 7 by 5 and 3 over 2. They both are improper fractions. And let's see the product also. 7 times 3 is 21 and 5 times 2 is 10. 21 over 10 is also an improper fraction. But here, the improper fraction will be greater than the individual fraction. This is just the opposite of what we have done in the previous slide, that the result of a proper fraction is smaller than the individual fraction, right? If it is written in this manner, I can also write 10 over 21 and 2 over 3. If I write it on another side, then it becomes inequality changes. That shows if I will write 10 over 21 on this side, then it is less than 2 over 3. Very simple, right? This symbol changes, but the meaning is still same. But the same thing if I write on the next, that means if I use for the improper ones. So here what happens, we can say here that the result in improper fraction will be always greater than the individual improper fraction. Let's take one more example here. If I take 6 over 2 and 5 over 4, the final product is 6 times 5, that is 30, and 2 times 4 is 8. So here we will also conclude that 30 over 8 will be greater than 6 over 2, as well as 30 over 8 is greater than 5 over 4 also, right? So what will be the concluding statement? It says, we have seen that a product here is greater. So the product of two improper fraction is greater than each of the two fractions. So just relate it, in proper fraction, we have the product as smaller than individual fraction, whereas in case of improper fraction, we have the final product as a greater than, we have the final product as greater than the each of the individual improper fraction. Or we can say the value of the product of two improper fractions is more than each of the two fractions. These are the same 3 lines but written in different languages only, so that you can understand it more clearly. Now, proceeding further, we have some questions which you can try on your own here. So, we can see some proper and improper fractions combination also. We have a improper and improper combination also. Try them on your own now and conclude the results.